name is Ehsan Abbasnejad. I am a senior lecturer at the University of Adelaide. I'm also a director at the Australian Institute of Machine Learning. I am also a future making fellow at the University of Adelaide. My field of research, as a lot of other people here, is AI and machine learning. In particular, I work in what I call responsible machine learning. So people know about responsible AI, making AI safer, more reliable. And what we try to do in myself and my group is to understand what machine learning, what these underlying algorithms that make these AI models and machine learning models work, how they work, and how we can understand them better so that we can make them more reliable and safe. A lot of people know that these models are trained on large amounts of internet data. In a lot of cases, there is not much supervision, or we can't really provide that much supervision because of the vast amount of data. But people have found that when you train these models on these large amounts of data, they are very good for other tasks. But what we try to understand is what's the relationship between the model that was pre-trained on large amounts of data and the downstream task, as it's called, and how we can better connect the dots in these pre-trained models. Basically, how we can understand these neural networks and how they process the data. We also look at applications of these models, and we try to use them in health, in applications in agriculture. We recently had a grant with some of the collaborators in the UK looking at wheat, how we can understand the protein content in wheat and sort them out. We've also done some work with the Australian Institute of Sport. One of them particularly was used in the Paralympics last year in Japan. It basically was a tool to help the coaches understand the players' rhythms and uncover what the potential opponents are doing so that they come up with better training for their players. So we recently also won a new grant in collaboration with some of the colleagues in France to look at energy, and especially renewable energy. We would have different sources of energy, and we have a diverse use cases for energy. And controlling that using AI is one challenge, but also incorporating human feedback and our preferences in using different sources of input, sources of electricity and power, as well as different ways and patterns that we utilize or we use power in houses. This year I was nominated as a finalist in the AI Awards, Australian AI Awards, as the AI Researcher of the Year. In my group, recently we had 2 papers accepted at NeurIPS. NeurIPS is the highest or top AI conference, and I'm really proud of the students and postdocs who worked really hard on those papers. This year we had papers at ICLR, which is another top conference in machine learning. It's the highest ranked conference in machine learning, and ICML, and it's the second highest rank. So I think from my childhood, I thought that brain is the most fantastic thing that we have. Basically, the whole world is reflected in how we process it. It's our brain. And I wanted to understand how it works and how we can engineer it. And I think that's a fantastic thing about this field, that we are trying to replicate what brain does, basically how it processes the input, how it imagines about things, right? And I think that's the most fantastic thing that I can think of about AI and machine learning, and what inspires me to understand that, okay, if you're changing some of the neurons, how they interact with each other so that we learn something, or how we can make that learning better. What I love most about being at AIML is the people that we have here, the colleagues, the other researchers here. We can bump into someone down the corridor and have some time talking about different aspects of research that they're doing and learn a lot. It's great to work with them, but also it's a fantastic opportunity to learn from these people and collaborate with them.